Dear students, good afternoon. Now we are going to discuss about the problem in cooling load calculation, especially in a summer air conditioning systems. Okay, let me go to the problem. This problem is taken from the book that is Refrigeration and Air Conditioning by Khurumi. Okay, first we read the problem. The room sensible and latent heat for a air conditioning space are 25 kilowatt and 5 kilowatt respectively. The room condition is 25 degrees Celsius dry bulb temperature and 50% RH. So this is a room condition that is initially, it is a condition number 2, 50% RH. This is a point room condition. You can assume it is set as a 2. Then outdoor condition is 40 degrees Celsius dry bulb temperature and 50% RH. This is a condition number 2. Okay, the ventilation requirement is such that on a mass flow rate basis of 20% of fresh air is introduced and 80% of recirculated air is used. The bypass factor of cooling coil is, that is 15%, that is equal to 0.15. It is a 15%. So from the given data, we are going to determine the supply air flow rate. First one, second one, outside air sensible heat. First, you are going to find supply air flow rate, how much quantity of air that flows to the cooling coil. Then second one is outside air sensible heat, outside air latent heat, then grand total heat. Last one is effective room sensible heat factor. So these are the parameters that you are going to find. So from that, you have to fix the point number 1 and 2 in the psychometric chart. Listen. In the psychometric chart, you're going to fix the point number 1 and 2. In the diagram, you draw the 25 degree Celsius dry bulb temperature and 50% RH. This 25 degree line, from that line you have to draw the perpendicular line. So it is equal to 25 degrees Celsius. Listen. So in a 25, you draw the line. Okay, from the scale, with the help of scale, you draw the line 25. The next one is at 50% RH. This is a 50% RH line. So you can meet the, okay, this one 50% RH line. In the 50% RH line, you get the point. So this is the point. This is the room condition. So fix this is the room condition. There is a point number 2. Okay. Then after that, you are going to fix the inlet outdoor condition. So outdoor condition is 45 degrees Celsius dry bulb temperature and 50% RH. Same 50% RH you draw, that is called as the 40 degrees Celsius and 50% RH. Just to draw the line in the 40 degrees Celsius, in the 40 degrees Celsius and the 50% RH line, you have the point. Just wait. Just to enlarge the line, extend the line here, it is a 50% RH line. So this is the point number 2. Here is the point number, 1. It is the point number 1. Okay, this is the point number 1. So mark point 1 and point 2. Then draw the straight line joining 1 and 2. Okay, from the psychometric chart, draw the straight line from 1 and 2. Okay, then after that, move to the problem. Okay, in the move to the problem, find the mixing condition. So before the mixing condition, you must find the room sensible heat factor, because in the problem the given room sensible heat is equal to 25 kilowatt and room latent heat is equal to, say it is a 5 kilowatt. So you are going to find the room sensible heat factor. What is mean by room sensible heat factor? It is a ratio of room sensible heat divided by, it is called as a room sensible heat plus room latent heat. Otherwise we can say it is nothing but the room sensible heat divided by total sensible heat. So it is equal to 25 divided by 25 plus the 5, you get the 25 divided by 30. Finally you can get the room sensible heat factor is equal to how much? That may be is equal to 0.833. Okay. Then next condition, you note that in the problem, from the given data 25 5 kilowatt, you find the room sensible heat factor. You noted the condition condition number 2 in the psychometric chart completed. Condition number 1 outdoor condition is also completed in the psychometric chart. So next to the point, the ventilation requirement is such that mass flow rate is 20% of fresh air. So if you are going to calculate the mass flow rate, here in the mass flow rate 20% fresh air and 80% recirculated air. So how we call exactly locate the mixing condition, that is point number 3. So this is the point number 1, you already fixed in psychometric chart. Point number 2 fixed in psychometric chart. You are going to look at the point number 3 in a psychometric chart. Point number 3 is a 20% fresh air and 80% recirculated air. Then we move to the psychometric chart. Okay, in a psychometric chart, you're going to measure the distance. You're going to measure the distance. The total distance is, you measure that is called as a distance of how much? Distance of 1 to 2. How much you from the scale you are going to measure. Here I am not going to exactly measure because I am going to minimize and maximize the psychometric chart so that I am exactly get that. You're going to measure the scale. From that distance, you are going to fix the point number 3. So point number 3 is equal to somewhat centimeter. So point number 3 equal to 0.8% of that centimeter. You are gives a somewhat centimeter. So from that centimeter, from the point number 1, you are going to fix the point number 3. So from the problem, you are exactly located the TD3, which is equal to, we are exactly located TD3 at a somewhat distance. Here at the temperature of the TD3 is equal to 20 degrees Celsius. Again, I am repeating, I am not able to mark the distance and exactly find the position number 3 because I am going to maximize and minimize the damage that I am not exactly get. So it nearly at a point of 28.3, you are getting the point number 3. Okay, so here that is exactly 25, 26, 27, 28, 28.3. You draw the line. So you draw the line from the 28.3 where it exactly touches. So this is the point where it actually touches the point. This is the point number 2. This is the point number 1. This is nothing but the 3. Now we are going to erase this one. Exactly locate a point 1, point 2, and point 3. Okay. Then you are going to find the room sensible heat factor line. So first step is marking a point 1. This is the first step marked. Point 2 marked. Then point 3 marked. These are the first 3 steps. Then fourth step is you have to draw the room sensible heat factor line. This is the fourth step. The fourth step is you are going to find the room sensible heat factor line. Already in the PPT you find the room sensible heat factor is nothing but 0.833. So at a sensible heat factor of 0.833, 0.81, 81, 82, 83. So this is a point 0.833. This is 0.833 room sensible heat factor. And we are going to fix the alignment circle. You are going to fix the alignment circle. Where are you going to fix the alignment circle? What is the exact point of alignment circle? Where is the exact point of alignment circle? Anybody answer? So you can mark the point number 2 at that place. Just wait. You can mark the point number 2 for our convenience. We have to mark a particular place. So what is the exact point of alignment circle?
Sir, between 2 and 3.
Between 2 and 3, not an exact alignment circle. I already told that is alignment circle. There may be fixed position. What is the fixed position of alignment circle? The fixed point of alignment circle is that is 23 degrees Celsius dry bulb temperature and 50% RSHF. This is a standard procedure to fix the alignment circle. So in the line you are going to mark the 26. So 26, 50% RSHF. This is a 50% line and this is a 26. Then draw the line 26 where it meets the fixed receptor. This is the alignment circle. Point number 3, which is the alignment circle. You erase this line. Then you put, this is the alignment circle. You mark it as a green dotted color. Then from the alignment circle to this particular point, you draw one line. Okay, you draw one line from 0.833 to just draw one line. Then by using a scale, okay, by using the scale, draw the line exactly parallel to 2 to 3, exactly parallel to 2 3. Sorry, you can mark that is called as, this point is nothing but the R, this is nothing but the R dash. You will draw the line of, draw a parallel line from 2 which is equal to R, which is parallel to R dash. So from R dash we can draw parallel line from a 2, it intersects to the, that is one particular point. Okay, this line you can mark that is a 2 2, we can say it is nothing but the 5. This point is located as a 5. So point number 2 to 5, this line is nothing but which line? 2 to 5. That is a room sensible heat factor line. Okay, room sensible heat factor line. Then next you are going to draw the grand sensible heat factor line. Before you draw the grand sensible heat factor line, second factor is nothing but grand sensible heat factor line. So how you draw the grand sensible heat factor line? We can draw the grand sensible heat factor line from the point number 3, which intersects the line 2 5. So yeah, from a point 3 which intersects the line 2 5, but we exactly located the point that is 6, or where it intersects the line 2 5. So we are going to calculate it from the calculation. Okay, going to calculate it from the calculation. Listen here, then the problem the given is, listen, where exactly it located. I already told the cooling coil temperature is nothing but the 6. Cooling coil temperature is nothing but the 6. Next you are going to study the bypass factor. So bypass factor. So bypass factor is equal to, what is the formula to write the bypass factor? Because it is the cooling coil. The air can enter at a temperature of, say, that is 3 and leave at a temperature of 4. The coil temperature is nothing but 6. What is the bypass factor? Which is equal to T
TD4
minus TD6 divided by TD3 minus TD6. Okay. In some book it can be written as, there is a TD4 minus TD6 can be ADP, that is called as apparent dew point temperature. That is called as coil temperature minus ADP. Then from the data, TD4 you doesn't know. TD4 doesn't know. TD6 also doesn't know. TD3 you know. So from the psychometric chart, you know the TD3 which is equal to 28.3. Almost approximately we can take it as a 28.3 minus TD6. Okay, so which is equal to bypass factor, what you given is, what the given in the problem is, which is equal to 0.15. Okay, 0.15. How we can find 0.4 and 0.6 in the psychometric chart? What is the exact procedure to solve this? Please observe, in a psychometric chart, you draw a line 3, 2, 6, you draw one line. Please note that. Approximately the bypass factor is equal to 0.15. So more or less it's nearly close to the 0.5. Okay, here you draw one particular line. Just a sample line, what I can draw in the brown color, please note that one line. So this is the point number 6. Okay, already we have a formula. So 0.15 is equal to TD4 minus TD6 divided by 28. We already know TD3 28.3 minus TD6. Here you note the value. Listen, from the diagram, you note the value. This is the TD6, where it is intersected. This point is nothing but, that is a TD4. You note that TD6 and TD4. This is a point number 4, and substitute the temperature value in that particular equation. 0.15 is equal to TD4 minus TD6 divided by 28 the TD6, this equation. You substitute this value in that particular form, either you get 0.15. No. If it is something large, okay, then you can erase this line. You can erase this line. If it is larger than 0.15, okay, then if you make the line somewhat intersect with the intersection is somewhat closer. So last line is make intersection, it is somewhat closer. Last time this line is slightly larger, here 6, 4. Okay, again you note the temperature at what is the TD6 and what is the TD4. Note the temperature. Then you substitute the TD6 and TD64 in the bypass factor equation. Either you get a 0.15. It is like a just trial and error measurement. You can substitute the value of TD6 and TD4 where it exactly equal to 0.15. You repeat the process up to where you get the 0.15. Okay, this gap plays a major role. Okay, this gap plays the major role because if it is bypass, you calculated bypass factor, it may be 0.12 means if you are going to enlarge this gap, if it is 1 pi. Otherwise, if the value is greater than 0.15, definitely you are going to minimize this area. You are getting this value. So from the trial and error method, you find the TD4 value that is exactly, that may be around 14 degrees Celsius and TD6 may be 11 degrees Celsius. So listen, the line after the trial and error method, you may fix the line that is 11. So this is the 11 and this is the 3. You draw the line between 11 and 3. And I just roughly draw this, but I am not exactly using scale. And this is the point number 6. This is the point number 4. Okay, then you make a measurement of this. Listen, then TD6, which may be equal to TD6. This is the TD4. Okay, and roughly I am drawing. So, but actually from the problem you got the TD6 is equal to 11 degrees Celsius and TD4 is equal to 14 degrees Celsius. I'm not exactly find that is a 14 or something. It may get some 15 or something. If using a psychometric chart with proper scale, you will get the exact value of 11 and 14 degrees Celsius. So this is the important criterions in the psychometric chart to finding the 4 and 6 with the help of bypass factor. In some problem, the cooling coil temperature may be given TD6. It is easy. Then you are easy to find. You draw the cooling coil temperature. You draw the line. Where it intersects the line 2,5. Exactly, you get the point number 4. That is the cooling coil outlet temperature. Okay. Then you draw the another one line. So this line is nothing but you draw the another one line. This line may be grand sensible. You draw the line 6 to 2. 6 to 2. So what is 6 to 2? So to grand sensible heat factor line, that may be the point maybe lies in the line of 3 to 6. Then next one is nothing but 2 to 6. That is nothing but effective room sensible heat factor. Okay, there is effective room sensible heat factor line. Then you may draw that point 4 dash. Here you can take a bypass factor of that particular following how it may be calculated from this line. Otherwise, by formula we are already calculating the bypass factor. Otherwise, if you are going to calculate the bypass factor, draw a line parallel to 1 and 2 from this 4 to this line. This is nothing but the 4 dash. Okay, so simply after that, you may take a value of enthalpy for all the points from the psychometric chart. So this is the enthalpy, that is the H6, H4, H2, H3. Then you may take the H1, that is H1 from this line. This from the H1. So H1 is not here. So this is the H1 value enthalpy. This is the H3, this is a H2, this is a H4, this is a H6. You may make the enthalpy at the particular points. So this is the data to find how enthalpy is found from the psychometric chart. Okay. Next we move to the substitution part of the problem. Listen, we already find the psychometric chart from the equation. The TD4 may be around 14 degrees Celsius and TD6 may be around 11 degrees Celsius. By trial and approximation, we find the factor. Okay. Then first we are going to find the supply flow rate. Okay, we are going to find the supply flow rate. What is the, how we can find the supply flow rate? First, before you are going to find the volume flow rate, then you are going to find that is volume is equal to, volume is equal to mass into specific volume. Here, we doesn't know volume, we doesn't know mass. Then how you find the specific volume? We may find the specific volume from the psychrometric chart, VS1. So we have a formula. That formula we can write the volume and mass. Room sensible heat factor. Room sensible heat is 0.2044 into volume into TD2 minus, that is a TD4. Already we discussed. We need to know TD4. TD4 we know to this value we already standard. The room sensible heat that we already find is a 25 kilowatt. So 25 is equal to 0.02044. V into TD2 minus TD4. So from that equation you are going to find then V is equal to volume flow rate is equal to 108.7 meter cube per minute. This is the volume flow rate of air to the room. This is the total. This is the volume flow rate at a point number 4. This is equal to 108.7 meter cube per minute. So what is the volume flow rate at 1? So this is the V4 we already find. What is the volume flow rate at 1?
Sir, 20% of V4.
20% of V4 because the 20% here it is a 20% of V4. So which is equal to that is 21.74 meter cube per minute. Okay, 21.74 meter cube per minute. So this is simple to find volume flow rate of total volume flow rate and then outside air volume flow rate. Okay, we find the volume flow rate. From the volume flow rate, we are going to find the mass flow rate. How we find the mass flow rate? By finding a specific volume at each location. If we find a specific volume at a psychometric chart at V1, small V1, okay, you find in the question the psychometric chart, you find that is a small V1, that is a specific volume line. Okay, you can minimize the chart. We find what is a specific volume line. This specific volume line may be like that 0.90, 0.92. So that exactly the specific volume is 0.92. So 0.92 meter cube per kilogram. So we know volume, we know specific volume. From that we are going to find the mass flow rate. Okay. Then next we are going to find first supply flow rate. We already find in terms of 108.7 meter cube per minute. Then we are going to find the outside air sensible heat. So we are going to find, second one, outside air sensible heat. What is the formula to find outside air sensible heat? So which is equal to, outside air sensible heat is equal to, we already discussed 0.02044 V naught into TD1 minus TD2. Because V naught is equal to, in a book formula, V naught is equal to volume flow rate of fresh air. Okay, because we are going to find the outside air only, not considering for entire air. So by substituting the appropriate values, the outside air sensible heat, which is equal to, that is equal to 6.66 kilowatt. This is the outside air sensible heat. The next one, third one, you are going to find the outside air latent heat. Here when you are going to find outside air latent heat. This is having a constant formula. Then outside air latent heat is equal to, which is equal to 0.50 V naught into, that is double omega 1 minus omega 2. So where we find the omega 1, omega 2? Okay, from the psychometric chart. On the point number 1, you draw the straight line, which is nothing but the omega 1. Point number 2, you draw the straight line. N is equal to omega 2. So nearly omega 1 may be 23 point something. Here we made a mistake in that making a omega specific humidity or humidity ratio. Here it can be represented moisture per kilogram of dry air. Here moisture per kilogram or per gram of dry air. There may be some differences between psychometric chart. In one psychometric it can be given in gram per kilogram of dry air. In one book it can be given as a kilogram per kilogram of dry air. Okay, from that it can be noted that may be 23 gram per kilogram of dry air. Here it is represent. Here it is the noted. Please noted that the value is gram. I think that there is a grams per gram moisture per kilogram of dry air. But in some psychometric chart, this is kilogram per kilogram of dry air. So here that may be around 23.8 something. That is omega 1. Omega 2. That may be around 9.9 something. By drawing a straight line from a 2, we are getting that almost 9.5. But the line was somewhat not straight. Okay. Then we substitute the omega 1, omega 2 in the respective equations. So here 50, we can draw this equation. There is a 50. V0 we already find which is equal to 0. V0 that is maybe taken as there is 21.74. Omega 1 that may be here you substitute 0.023 minus 0.098. 0098. But in the chart we find there is a 23 and 9. It's a 95, 9.5. What is how I write the 23 as 0.023, 9.5 as 0.905? Because these values are given in the grams per kilogram of moisture in a psychometric chart. But in a substitution, we written this term as a kilogram per kilogram of moisture in the substitution. So that's why I divided by 1000. So after this substitution, we are getting the outside or latent heat is equal to, so which may be outside or latent heat is equal to, that is called as a 15 kilowatt. Okay, then third one what asked in the problem is, listen, third one is nothing but we are find outsiders and outside latent. So fourth one grand total heat. So listen, fourth one is nothing but the grand total heat, which is equal to grand total sensible heat is equal to, that is equal to, just wait, grand total heat is equal to, that is a total sensible heat plus total latent heat. So here total sensible heat that can be defined as the room sensible heat plus outside air sensible heat. Then total latent heat is equal to room latent heat plus outside air latent heat. Okay. So we already find there is a 25 plus 6.66 we find. In the problem it can be given as a 5 plus 15. Exactly we are getting it is equal to 20. Here it is equal to 31.66. Both are in a kilowatt. In fourth parameter you find there is a what is the grand total heat. Okay, otherwise you are going to substitute with the help of a formula. Okay, 20.00 in 4 into something we are going to find. Okay, then fifth one what you are going to find is effective room sensible heat factor. So fifth one is nothing but effective room sensible heat factor. So effective room sensible heat factor, which is equal to ratio of effective room sensible heat divided by effective room total heat, so which is equal to effective room sensible heat divided by effective room sensible plus effective room latent heat. We already have the formula. So effective room sensible heat is equal to, what is the formula? That is a room sensible heat plus outside air sensible heat into bypass factor. Then effective room latent heat is equal to room latent heat plus outside air latent heat into bypass factor. Okay, so after the substitution, we are getting the value of that is equal to effective room sensible heat is equal to 26 kilowatt, which is equal to 7.25 kilowatt. Then you substitute the appropriate values. Then effective room sensible heat factor is equal to 26 divided by 26 plus 7.25. So we are getting effective room sensible heat factor is equal to, that is almost equal to 0.782. Okay, we find all the five parameters, that is our effective room sensible heat factor also. Okay.